of you might know our speaker, but I'll give him a brief bio. So Eric Udd is the president of Columbia Gorge Research and has been deeply involved with fiber optic sensors since 1977 and has helped pioneer early work on fiber optic gyros, fiber optic smart structures for health monitoring, multi-axis strain sensors, high-speed fiber optic sensor systems, and fiber optic pressure and temperature sensors. He worked for McDonnell Douglas from 1977 to 1993, where he managed over 25 DoD, NASA, and internally funded fiber optic sensor programs. He held a series of positions moving from engineer and scientist to manager in fiber optics, and in 1987 was appointed as one of the 40 McDonnell Douglas Fellows. He invented, designed, and built the first closed-loop fiber gyros and worked on major undersea fiber optic acoustic sensor programs for the Navy in the 1970s. Udd's work on fiber optic smart structures resulted in the instrumentation of the composite hydrogen tank of the Delta Clipper to measure strain and temperature to assess its condition after each flight. The success of the Delta Clipper inspired SpaceX and Blue Origin to further develop vertical landings and reusable launch vehicles. In 1993, he started Blue Road Research and directed the growth of the company through its acquisition by Standard MEMS in January 2000. In January 2006, he left Blue Road Research to work full-time at his new company, Columbia Gorge Research. Columbia Gorge Research is strongly focused on the objective of moving fiber optic sensor technology to the field quickly and efficiently, supporting both end users and developers of the fiber optic sensor technology by forming synergistic relationships with other companies and organizations. His efforts at Blue Road Research and Columbia Gorge Research have involved applications in aerospace, defense, civil structures, composite manufacturing, robotic surgery, oil and gas field services, electrical utilities, surveillance, and energetic materials. Udd has 54 issued patents, with many issued internationally, written over 200 papers, chaired and helped organize 39 international conferences on fiber optic sensor technology. His books include Fiber Optic Sensors, an introduction for engineers and scientists, Fiber Optic Smart Structures, Field Guide to Fiber Optic Sensors, and Design and Development of Fiber Optic Gyroscopes. Mr. Udd is a fellow of SPIE and Optica and a lifetime member of the IEEE and the IEEE Photonic Society. He has been awarded the Richardson Medal for 2009 by the Optical Society of America for his work on fiber optic sensors and the field of fiber optic smart structures. He has taught courses since 1978 for McDonnell Douglas, SPIE, UCLA Extension, Optica, NASA, the U.S. Air Force, Navy, Army, and NATO, as well as many companies and organizations on fiber optic sensors, fiber optic smart structures, and small business. He has a BS in Math and Physics from the University of Washington in Seattle and an MSc from Princeton University in Aerospace and Mechanical Science, where he was a member of the Electro-Optics and Applied Physics group. So with that, I'll turn it over to Eric. I'm very excited to hear your talk, and I know that everyone on this line is as well. So thanks, Eric.
Okay, I'm trying to share my slides here. There we go. Okay, let's try it here. Right. So hopefully we can see this. I'm going to spend the next.
So Eric, unfortunately, we don't. I don't see it on my end.
Okay, let's try it again.
It might just be to the lag. Yeah, yeah. We have a lot of people on the line. You're very popular, so that's probably why it's sharing now.
Oh, okay. All right. So what I'm going to do over the next hour or so is give you an overview of this window here, of how to start a small high-tech business and some of my experiences of doing that in Troutdale, Oregon, which is not exactly an optimal place to start a new business in high tech, and hopefully give you some ideas on how to start a business, what is involved in the starting process, and also a bunch of tips along the way. Things I've learned.
And Eric, we're still just, it still says starting to share content, so I'd maybe try to reshare.
Let me stop this. Let's try share again. Maybe this one. How about now?
Yes, we can see it now.
Okay. So I'm going to hide this.
Yeah, no worries.
Okay. So I'm going to start rolling through these things. I already had a pretty thorough introduction. The short form is I worked at McDonnell Douglas from 77 to 93. learned a great deal about how to run programs and how to win contracts and other things, and used that knowledge to start Blue Road Research in '93, and left Blue Road Research in 2006 to start a second company, Columbia Gorge Research, which I still have. So there's two different startups, different modes of operating both of those, and different motivations. And we'll go through some of that. If you're interested in the technology that's associated with that, you can look at Google Scholar and look at my citations for papers and patents and so on. And there's 4 books that kind of are chronologically explaining what I've done. So McDonnell Douglas era, the first edition of the fiber optic sensor book for Wiley kind of covers that. And it continues with a book on fiber optic smart structures. And then I have a second, and recently this month, the 3rd edition of a fiber optic sensor book is coming out, which kind of updates what I've done. And they're edited. So I've also included many chapters with people I've collaborated with over the years, so you can get a feel for what's going on. And the fiber gel work is summarized in the 2019 book. So there are 2 parts to this talk. The first part are roughly the first 6 bullets here, through motivation, through evolution of a small high-tech business. And it's to give you a feel for, okay, I'm in a business, or I want to start a business from scratch. How do I go about doing it? Am I motivated enough? Do I have the resources available to succeed, and so on? How do I set it up and get rolling? And the second part is on tools. And there are elements of starting a business, and it includes a bunch of things that would have been nice to know a little bit sooner rather than later. So I'll roll through those with you as well, roughly in the second half of the talk. So the first question for motivation is, why do you want to start your business? What are you willing to give up for it? It's a lot easier to stay employed by somebody else who's taking the risk. It's lower stress. It just is easier. You don't have to do everything, which is what you have to do with your own business, especially if you're starting from scratch, using your own funds, or limited funds. It can be quite an increase in workload. Also, it takes roughly 3 to 5 years for most successful high-tech businesses to reach some kind of stability. Before that, you're investing heavily in time, energy, and resources, and you have to make sure that you have available resources, motivation, commitment to stay alive during that period. Now, why would somebody want to do this? Well, maybe they want a more direct relationship between effort expended and reward. You may or may not get that in a company. In my case, I'll go through this a little bit later. There were family reasons. My wife wanted to move back to the Pacific Northwest from Southern California, where I was located with McDonnell Douglas Astronautics Company. So it was driven by family reasons. There may also be difficulties when you're in a large organization that you don't like. Maybe you work on something and the organization decides they want to work on something else, and suddenly you've invested a lot of time, energy, and suddenly it's not there anymore. You have a chance to bring a product or technology you're fond of and want to see succeed in the field, actually to market and be fielded. Potentially you can build a legacy, and if things work out, there may be financial rewards and stability. So this is my specific example for why Troutdale, Oregon. My wife wanted to move back there because her parents were having fairly severe health problems, and she wanted to move back from the Pacific Northwest, from Southern California. And we had 2 small children, 2 daughters, and we felt, well, gee, we'd like them to get to know their grandparents. So some of the disadvantages was I didn't know anybody doing fiber sensors in the Portland, Oregon area. And of all the cities on the west coast of the US, I considered it the Death Valley. of the West Coast because there was nothing here. So in order to move there, I wanted to recreate my job at McDonnell Douglas, which was leading a group of about 15 people. And actually at the end, I was a McDonnell Douglas fellow with a working group of 200 people throughout the corporation. But I wanted to continue to do what I was doing. And the only way I could see doing that was to create my own company. There were other issues associated with Portland not really having a university anchor for high tech. The major universities were Oregon State University and University of Oregon, which are in the middle of the state, not exactly nearby. And they had some optics activity. And we're also located at the extreme east end of the Portland metro area, which is diametrically opposite where the high-tech area involving semiconductors and Intel and some other companies are on the extreme other end of the metro area. So it wasn't exactly conveniently located. Okay, so you decided you're going to go ahead with this. What do you need in terms of resources? Well, if you're going to take 3 to 4 years or 5 years and to reach break even, you need the finances to get started, and you need to figure out how are you going to generate revenue so you can reach a stable operating position. And you need some sort of plan before you start this enterprise. And you have to be prepared to modify the plan because everything that you think you might be doing might not turn out the way you expect. Second thing you need is you need a collection of talents and skills that will enable you to operate the business, operate the technology, and move the products to a successful conclusion. You need connections with customers and who's going to buy your products and when will they buy your products. Oops, went the wrong way. So again, you need 3 to 5 years for startup and financing. Well, how do you do that? Well, you can mortgage your house, which is the way I did it the first time. We used the sale of our house to buy a building and property from my wife's family and got them to agree to loan back the money from the purchase to help us start up. You could have savings, and I use some savings, friends and relatives. Maybe you have a partner. Maybe some of the partners work and you run the business. It's less likely that banks are going to be wildly enthused about starting you up if you're just starting from scratch and have no track record. And the venture capital guys are not going to pay attention when you're on the wrong side of the investment curve. So you need to lay out some sort of plan for your startup and be prepared for some sticker shock and potentially some anxiety. Because this is what a typical investment curve looks like. You're starting out, you're cranking away, trying to get started, trying to build up your capabilities and move toward having something to sell. And if this curve is too steep and you don't plan well, you'll eventually run out of money and that's the end. So you need to tend to reach or move toward a stability point, this flat area where the money coming in is matching the money coming out, and you start to go up the other side of the curve when you start recouping what you've invested. And that can take quite some time too. So depending on how deep a hole you've dug, it's going to require some time, years, to probably fill in this hole and break even if everything works out. So getting back to how you break even, you need to be able to sell something. And what is it? Is it consulting? Is it a product or products? Is it some services? Are you going to develop intellectual property and license it? Can you do courses, educational things to probably reduce the investment level? Is there a market for your products? How big is it? Do you have any experience in that marketplace? And if not, how do you plan to access it? And do you have short, medium, and longer term plans on how you're going to do all this? Where you're going to start and where you're going to? So when I started Blue Road Research, this is my first company. I had 16 years of experience working at McDonnell Douglas. I led a fiber optic sensor group for most of that time, and I knew how to do proposals and win contracts. I had experience being principal investigator on many efforts. I knew how to do patents because our patent department at McDonnell Douglas was too busy, and I wound up preparing most of the patents myself, except for the claims, which I collaborated with the lawyers. So I knew how to do patents, and I had a lot of contacts that I developed over this period throughout industry. And I knew how to manage technical programs and manage people. And I used the equity of the sale of our house in Southern California to support buying a house and some acreage around it and building what turned out to be the shell of a building for Blue Road Research on the property. And I used some of the revenue from the savings plan and patent royalty to kind of finish things off. I had patent royalties coming in from McDonnell Douglas licensing fiber gyros worldwide. So that helped with some of the investment costs for buying equipment that I needed. For Columbia Gorge Research, when I left Blue Road Research, I had 16 years of experience at McDonnell Douglas, but now I had 12 years of experience with operating a small business. I'd gone through the ringer, if you like, of basically being able to understand how to run a small business, what worked, what didn't work. But I wasn't going to remortgage my house. I decided I'd use a 5-year IRA withdrawal, which with US laws you could do without paying a penalty, provided you use an actuarial system to do it. And I used the cash flow to help underpin the startup process. I also had a much wider contact base with people, especially in Oregon, and that helped. And I also had the building, when we started Blue Road Research, we operated out of a building that eventually, when the company got acquired via a stock swap with a bigger company, we moved to a business park. So I retained the building and the property, so I had it pretty much set up and ready to go. So with both companies, I wanted to start out with, well, a mission and a vision. What's your company going to do? How's it going to do it? And you need some sort of statement for yourself and other people. If you have employees or people you're talking to, what's your company do? And what do you intend to accomplish? So with Blue Road Research, this is the mission and vision that I originally wrote out before I got going. So I wanted to continue to develop fiber optic sensor technology. I had a bunch of things I had been doing in education with teaching courses, consulting, R&D, fiber sensor products associated with McDonnell Douglas, and intellectual property and licensing. And I wanted Blue Road Research to move the technology to the field with partnerships. I figured I couldn't do it on my own. I'd have to partner with other companies and organizations to be able to actually do what I wanted to do, especially initially when I was completely on my own. And I wanted to seek and develop opportunities that would cross traditional boundaries. I'd done that initially with fiber sensors and smart structures to do health monitoring of rockets and airplanes and aerospace vehicles. And I wanted to be able to do that with other people because I thought that'd be an area that would be new and novel and give me an advantage. With Columbia Gorge Research, I'd already been doing those activities for quite a few years. I still had the fundamental basis of core skills and things that I had been doing that I want to continue. But I decided that I did not want to recreate my job at McDonnell Douglas, and instead of having 15 people and working really hard bringing in jobs to keep them all employed and moving, I decided that, well, I'm going to try and keep the employment level at a minimum. I'm still going to do R&D, but I'm going to work more on trying to help companies, larger companies, develop the technology they need to succeed in new areas. So it's going to try and reduce the workload with administration and employee management and bringing in new business and try to get more engaged in the technology again. So this is the diagram. Before I started either company, I spent about a year trying to figure out how I was going to create a company up in Troutdale, Oregon, and moving from the Huntington Beach in the Orange County area in the heart of lots and lots of high-tech activity to an area that had really nothing in the fiber sensor, fiber optics area that I knew about at the time. So the idea was, okay, I've been doing courses since 1978 for McDonnell Douglas and then SPIE and then the Optical Society of America, now Optica, and also UCLA Extension, actually some commercial companies. So I had a revenue stream associated with education. I had my first book out, and I thought, well, I could maybe do videos and maybe workshops and things. I could do consulting, which was similar to what I was doing for parts of McDonnell Douglas all over the place, helping them with various problems they had on projects. I'd done R&D, I developed some products, and I knew about intellectual property, and this would be what I'd build the company around. And for Blue Road Research, I was trying to move toward, okay, I'm going to concentrate on R&D that leads to products and have a stable organization and kind of recreate what I had at McDonnell Douglas. And again, for Columbia Gorge Research, I was going like, well, maybe I don't really want that. I want something that's a little bit different for Columbia Gorge Research and more emphasis on helping other companies achieve their product goals and less on having my own internal products, although I still wound up doing some of that. So this is what things look like, how things changed. So initially I'm starting from scratch pretty much on any revenue I can get is mostly education consulting, some R&D, but relatively small slice. And as time went along, I started winning contracts, both from the government and commercial contracts. That led to initial products. The education consulting continued, but the pie actually started to get bigger. So the amount of revenue we generated got bigger. The concentration on education consulting went down, and this continued as we went on. The number of products we had increased, and it turned out that the profits that we earned from products turned out to be much more than we get from R&D. If we had an R&D contract from the government, it would be lucky if we broke even. We might earn a few percent, but it'd be very low. And on some of the commercial endeavors, again, we may not have earned anything on that, but we learned things that could result in products. And for the products, we basically would figure out how much that the product would cost us to make, and we'd double it, and then we'd sell it. And so our profits primarily came out of the product sector. So this was the pathway for Blue Road Research. For Columbia Gorge Research, when I started again over here on the left-hand side, what I mainly wound up doing was going in this direction again, but realizing that, well, maybe I wanted to move back and forth. So I had a product slice, but I never made it too big. I had an R&D slice, but I found out I was doing more and more consulting in the process of helping other companies. So I was doing R&D for other companies rather than as much internal R&D. So I didn't divide this up, but the internal R&D slice went down, and the government R&D slice went from a relatively big section in the early years of Columbia Gorge Research to my going like it's too much paperwork and doing less and less, in the end, almost none government research. It was all commercial because it was easier, faster, they paid more, and it was getting more in line with what I wanted to do. So if you have products, you have a number of options. You can license the technology out to other people to manufacture. You can develop and market it in-house, and it can be a nice source of revenue for you. Or you can potentially build it up and spin it off into another company if you want, if it's a product that makes enough sense. This is the building I'm sitting in now on the upper left-hand corner in Oregon, and some of the early days equipment. Those trees are very small because that's when we first started. They're now way over the building. But there were some difficulties, especially in the early days, that that building was not finished. The house wasn't ready to occupy. We wound up in kind of a cabin about 20 some miles from here while we were waiting for the house to get finished. And it's pretty difficult to work from home when you have small children. Ours were 5 and 7 at the time, so they were pretty much, if I was home, wanting to spend time with me. So it's nice to have a separate facility, a separate place to go, especially if you have small children. And it took about a year to get that business building finished. And also, I did not have a whole lot of support from my wife that I kind of expected, because her mom's health deteriorated quite a bit. And that kind of ended her support for about 18 months. It's also difficult to work alone if you start by yourself. And the question is, can you handle that? Should you start with partners? That's something you might want to think about. All the potential customers were out of state. They were on the East Coast, California or Washington. It took about 5 years before I got anything at all from the Oregon DOT. And I spent a lot of time talking to them before we eventually got started on a project. And also the internal government contracts with small business innovative research contracts are pretty hard to win with a single person initially. And if you don't have any track record of performing on SBIRs, it's crucial you overcome that difficulty. And the way I did that is I would team with other groups and companies. Another thing I didn't really expect is I thought, well, I'm doing all this stuff for McDonnell Douglas. They'll probably help me by, allowing me to work part-time for them, helping out remotely. However, there were some people in management that went, well, Eric will be back and we really shouldn't help him. And so basically none of that really occurred. So it was an interesting situation, but I did manage to license from McDonnell Douglas kind of in exchange for a bunch of freebie help on the patents I hadn't quite finished yet. Reasonable licenses on technology they had not licensed out, and that was useful. Instead, Sandia Livermore, who had tried to do some things with McDonnell Douglas when I was there, but management decided they were not going to do anything with them because of it basically boiled down to they wanted me to concentrate on the aerospace projects and not what Lawrence Livermore or Sandia Livermore wanted to do. So they approached me not too long after I got started. We did some things together. They also helped me get introduced to some people in the mechanical engineering department at Stanford. And that turned out to be very useful, brought it some funding. Also, Production Products, which is a company doing composite material, had some people move in from McDonnell Douglas there who realized I'd done a lot of things on fiber sensors, and they were doing composite materials, and I helped them supply the technology for fiber sensors that enabled them to win a couple of DARPA programs and was a subcontractor. So these kind of efforts, in addition to the educational side and other things I was doing, helped reduce the investment load in the early days, and also form partnerships that helped me win my first SBIR contract, which really took, on the bottom there, 3 years before I got my first contract from NASA. And that's basically how the transition occurred between not really being stable, having to invest, to about 4 years later, took to about 97 before I reached the point where I could honestly be in break even. So that's the early days of Blue Road Research. I also used selling land to basically buy back the house, if you like, from my in-laws. I deferred a lot of salary because I needed it to basically buy equipment and so on to help overcome the initial difficulties. And I like the quote from Churchill of never, never, never give up. In many respects, it ought to be a business motto because things can be a little bumpy. I want to talk a little bit about selecting the technology associated with starting a company. In my case, I took the two that I thought were most promising. Fiber grading sensors that I've been working on for smart structures, and interferometric fiber sensors, which I'd been using for a number of different things. So I had licenses on the McDonnell Douglas base for the stuff I'd done there, that except for fiber optic gyros and a secure communication system. And the idea was to take that technology and to broaden the reach into other market areas with other partnerships using that fundamental technology base. And that's what I did with Road Research, and that's what I did with Columbia Gorge Research, is use the same technical base. And initially, when I was looking at markets, I was very familiar with aerospace. I'd done a little bit in oil and gas with McDonnell Douglas, but eventually they told the oil and gas people to go away because they wanted me to concentrate on big aerospace contracts or projects that could result in many cases, billion-dollar level product lines. But when I left McDonnell Douglas, there was all these other possibilities of civil structures, which I was bugging the Oregon Department of Transportation about, composite manufacturing, which I was partnering with production products about, and some naval applications. And as time went along, that broadened, especially with Columbia Gorge Research, into the medical field with robotic surgery and electric power, with health monitoring of large transformers, some environmental monitoring. So the market space continued to expand with my efforts in the small business space. So this is to give you some idea of what I started with for an application. The driver for my initial work at McDonnell Douglas was to provide the guidance and control group with a look at what optical gyros could do in the guidance and navigation of the Delta rocket. So out of that, I came up with a new method of implementing a fiber gyro that would enable it to have the dynamic range and linearity needed for the Delta rocket. That was a closed loop fiber gyro. And I came up with that quite quickly after a few weeks at being at McDonnell Douglas. And that started a series of events where the Air Force got interested. We got Air Force contracts. We had lots of internal support, and a bunch of derivative inventions fell out that resulted in a big Navy program. And short form is by 82, I had about 15 people and I'd won a contract on an undersea program for another 20. And things were taking off. I had to have other people run the undersea program because it was too much to handle by myself. And it kept on into the area of smart structures. And the last thing I did at McDonnell Douglas was to design a system to measure strain and temperature on the second large DARPA program. It's about an $18 million program to look at fiber optic smart structures and all sorts of composite materials. It was mainly a composite material program, but we put on fiber optic strain and temperature sensors onto the composite hydrogen tank in the Delta Clipper, which is a single stage to orbit vehicle. This is a third scale model that was built into the Strategic Defense Initiative, and it's the precursor to the SpaceX and Blue Origin takeoff and landing at the same spot, except it was doing it in the early 90s. And the idea was to be able to do automatic health monitoring, so you could turn this around quickly. You could tell whether or not that hydrogen tank was intact when you landed, so you could refuel it and fly again. And I think it may still hold the record of turning around a vehicle in 24 hours for that kind of launch. So there were some holes in that system. And one of the things that was needed was a multi-axis, multi-dimensional strain sensor, which is this element over here. So you have a light source, many different sensors that are supported by it, and then you have a system for taking all this information back and processing it. And so what I did with Blue Road Research is come up with a better way than I ever had at McDonnell Douglas. After a couple of years, I figured out a way to measure three-dimensional strain instead of just one-dimensional strain with a fiber grating. And another invention was to measure pressure and temperature at the same time, so multi-parameter sensing. And that became the key technology that really enabled me to move into products with Blue Road Research. And these are some of the things that I did at both companies, some civil structure work of health monitoring systems for bridges and measuring traffic and weighing people and telling how fast they're going when they go across the freeway, the I-4 freeway near where this building is that runs from Portland to Boston. You can tell how much people weigh and how fast they're going. You can even measure, this is 1999, you can measure a jogger on the bridge walking, jumping up and down and walking off here. And this is Caltrans Bridge by the UCSD in San Diego that we helped with some space shuttle tanks. We were measuring where they would fail to help them requalify for additional space shuttle flights, some pressure vessels for Edwards Air Force Base, and some of the things we did in pressure and temperature for oil and gas is a double hole system. Anyway, there are many different things that we did. So the point there is you want to have a technology that is unique and compelling that ideally no one else has. So it should be compelling technically, and it should be compelling economically. So you need to search for, hopefully the ideal condition is if you had something to start with, but if you don't, you have to come up with something in that investment period that would potentially allow you to get in that space. I had some McDonnell Douglas licenses, but it was the ones that I invented later that actually launched the company, got the first SBIR, and also resulted in a product base. So that's what you're looking for. And you have to be careful that it makes sense, again, technically, ideally unique. And if not, it's got to be way, way cheaper. Because if you're trying to do something equivalent, you're going to have a heck of a time trying to displace the existing customer. So these are some of the things associated with what I've done. I'm going to skip ahead because we're taking a little more time here. The next thing you have to do is establish some sort of structure, staff, and so on with business growth. And you have to continue to survive long enough to hopefully pay yourself back. You probably also need to have reserve funding because eventually when you have a bunch of people, you have good times and bad times, and it costs a lot to get people in place in terms of time, money, and energy. And if you can keep everybody and avoid layoffs, it improves morale. And when things get good, things can take off much faster. So now I want to spend some time on tools. What you need to actually set things up. So I'm going to go through each of these, corporate structure, accounting, and so on. So I think I'll just start on it. So the first thing is, how do you set up a corporate structure? And there's different ways to do it. This is more or less following the US model, but I think it's similar for other countries too. You can do a sole proprietorship extremely simply. You just pick a name and off you go. And for the US, you fill out a separate sheet called the Schedule She for your taxes that accounts for things like, well, how much have you spent on the business? Are you making money, losing money? And you have 3 years you can lose money before they will examine you closely and whether or not you really are a business or something else. So it's relatively simple to set up and you're in business. The problem is there's no shield for legal liability. If somebody decides to sue your company and you're a sole proprietorship, they're essentially suing you. And so if you're actually successful at something and potentially somebody decides, well, if we sue these guys, we can get a bunch of money, you can become a target. But if you have minimal income and something that's not likely to get you in legal trouble, it's okay. So I actually set up a sole proprietorship when I started teaching courses because I figured, well, it's open literature courses, it's really a low risk, and I use that to basically buy my home office equipment to help write my first book. And I understood how that structure works. But when you actually go about setting something up that's more serious, like full-time effort, it probably makes sense to set up some sort of corporation. The simplest one to set up is a limited liability corporation, which looks a lot like a sole proprietorship if it's a sole owner limited liability corporation. It can also use a Schedule C. It does provide some legal protection if somebody is suing your company over a product you've made or whatever. Your company can go down the hole and die, but basically you're protected. Your assets are more protected. So you still have to file with the state to set this up. It's really simple. It's like a 1 or 2 page filing form. It costs $100, I think now, and the annual report is $100. It's really easy to set up. The ideal thing here is that it again looks like a lot like a Schedule C thing. The profit and loss rolls right to the owners. And if you have partners, life gets more complicated. You have to split it out. You probably need help from a CPA to help you do that, at least initially. The next step up is you can set up an S corporation. And this looks a lot like a regular corporation. You can have partners, you'll have stock registers, you have articles of incorporation. And unless you want to spend a lot of time studying how to set it up, you probably need a lawyer. The principal advantage here is profits and losses continue to roll to the stock owners. So if you have a loss, you can deduct it on your taxes. There are significant issues with stock ownership and how it's set up. It is quite possible that you can have problems between partners here. If one partner invests a bunch of money, has a loan, charges loan interest, it takes all the deductions initially, and then the partner who's maybe the technical partner comes along and and wants to buy the business back, they have to pay the loan to the investor, which is already written off on his taxes, but not yours. And then you also have to buy back the shares of the company, which they probably are going to charge you a premium for. And basically, if you're the minority person in this kind of operation and you don't invest a lot of money in upfront and you don't control the company, you can be in, it'll be really painful to get your company back if you're the one who did most of the work. So that's a warning. Another way to set things up, and this is the way I initially set up Blue Road Research, is as a C corporation. The advantage here is that while you cannot take losses, the losses belong to the company and not to the investors. They kind of flow, they don't flow down. So, but the good thing is the tax rates, especially when you're making money, this is much better when you're making money. When you're just starting out, the LLC probably is a better way to go. Maybe an S corporation. But in any case, the C corporation, if you're trying to grow the company, the tax rates are generally lower than the individual tax rates. So if you're trying to have a reserve built up in your company, in your C corporation, it costs less to do it this way generally. And it allows you to grow the company. Again, you probably need a lawyer to set up the C corporation. It's more complex in terms of annual reports and so on. The paperwork is more involved. So when the company is a little more established, that makes a lot more sense. Now you also need accounting and records. The requirements on a business, tax-wise, at least in the US, are more complicated than for an individual and more stringent. You have to pay attention if you want a government contract. You have to establish some sort of reasonable salary. You have to track hours. You have to have some sort of accounting methods. And initially, if you're not bringing much in, it could be as simple as a shoebox where you do your own accounting and you basically put your records in there and you pull them out periodically to get them in line. But over time, if your time is more valuable than somebody you can hire out to, you should really be doing that. So you can hire some people out part-time. If you grow enough, you can have a full-time accountant controller, but you don't want to do that before you need it. But you need to get ready for a government contract and you need to have an accounting system and it needs to be in the proper form because otherwise you're not going to get a major contract. For salaries, you have to balance between the financial needs of the company and having something that's sufficient to attract people to be your employees. And when you hire somebody, especially full-time, you've got things like vacation and sick leaves and health insurance and dental insurance and disability insurance, and pretty soon, whatever you're paying the person, you probably have an additional factor of at least 30%. And in our case, to make it more attractive, we had a retirement plan that was an additional 15% on top of that. So it's pretty easy to get into significant overhead just associated with the employees. The next thing to consider is you're going to have to spend money to go out and market and visit your potential customers, write proposals. You also have costs associated with your facility and maintenance and laboratory expenses and office expenses. So it's not unusual for you to have bid and proposal costs that are 60 to 100% of labor costs and facility costs that are high. When you're just starting out and just investing and just setting up, those costs are going to be higher than this. So when you add all those factors together, a company that just starts out may have a fairly astronomical high-end overhead rate, if you're being honest about it. As you start to move further along and get to a break-even point, for those years, you'll have a lower overhead rate, although you've incurred all this debt because you've essentially been paying all the overhead to get you started. And for attracting customers, especially government customers, they generally do not want to see a really high overhead, and 300% is way, way high. 100% is way, way low. You might want to have a low overhead and actually charge a commercial customer maybe even less than your costs to get something rolling. But for the government, eventually they want to see that your costs match what they're actually paying you. And the magic number seems to be about 200%. That seems to be about what they want to see after writing lots of proposals and talking to other small business owners who've been successful in the government side of things. That seems to be a magic number. Okay, so again, before you get any government contracts, you have to have your accounting system in line. The nice thing about government contracts, at least from the US government, from DoD and SBR contracts, is once you get them, the risk is lower and they're more patient. They're more likely to see you through to the end. Although the way they've set a lot of these things up is they give you 6 months to essentially demonstrate that you're worth it before you're eligible for a more generous 2-year contract, which much better funding to actually make something happen that they want to see happen. The commercial side is more simple in terms of they don't really care. You can offer them whatever rate you want and they'll probably accept it, provided it's a reasonable rate. And once they realize you need them, you may be able to charge a little bit more to make sure that you're doing okay. But they can drop you instantly. So you may have a contract or something's going with them, but they generally will tell you we're done. Maybe their upper management changes direction. Maybe you've done everything you can for them and it just gradually ends nicely. But anyway, it's much more volatile. Okay, so I already went through the overhead rate idea. Then the idea is managing yourself or organization. So these are some of the organization issues of managing yourself, adding people, and so on. We'll roll through some of these. So think of running a small business as a marathon and not a sprint. And it's important that you establish a regular pace for your work routine. You follow it. Remember what your objectives are, but you need to stay healthy. Things like diet, exercise, sleep, family, social time to keep you sane. Those are all critical. And it is true, the effort rewards system is closely linked. You have to work pretty hard to actually make things happen and reach a stability point, unless maybe you're more of a genius than I am and have this wonderful idea and can do it instantly. But everyone I know who succeeded really works hard, and it takes a while. So you have to plan for a sustained effort, and it's better than working horrific hours for months or even years and collapsing and burning out. And I've known a couple of people who have, burned themselves out and actually died in the process of overworking themselves. So don't do it. The whole objective here is to live your life more fully and hopefully get to a point where you're doing something you want to do and enjoy it. So be careful how you operate. The people I know that succeeded have all had a marathon approach. Another thing about the sprint situation is I think the worst decisions I've ever made is when I actually pushed myself too hard for too long. And the best decisions were ones where I did it in a relatively calm period and thought about it carefully. So be careful about making important decisions if you're in, okay, I'm really pressing here mode. Wait until you reach a relatively calm period to make something that's an important decision. And from time to time, give yourself time to think about what the personal cost of what you're doing is, and if necessary, readjust in favor of yourself. Okay, so how about adding people? Well, the first temptation is, especially when you're investing money, is to try and do everything. You can get supposedly some free help from your local small business help center or whatever, but my experience has been for a high-tech company, it's a little rough because they're used to opening maybe an ice cream shop or somebody selling whatever, and not too much in what to do with a high-tech company coming in. So if you're in an area where there isn't a whole lot of high-tech companies floating around, that may not help you a lot. But maybe talk to other people who you know or contacts about how they've got started, and look at business books to help you out. When you have support services you need, hire them out for people that do it part-time is probably the way to go, especially when you reach the point that rather than learning it yourself, if your time turns out to bring in more cash than the people you're hiring, that's great. That's what you should be doing. So initially consider part-time support that you can hire outside. And when you get to the point that you're so busy that you really need to add full-time people, you need to be really careful about that process. So if you're trying to be conservative on your investment side, you wait till you really need people, then you start looking for them and you try and look for them in the best possible spots. I knew people at the Oregon Institute of Technology and Oregon State and all over the place when I started to need people, and I relied on their recommendations heavily on people I even interviewed, and it worked out pretty well to be really careful. So a couple more things about adding people. You have a choice between adding people who are experienced or new engineers, people that just come out of school who may or may not have anything to do with what you need in terms of technology experience, but at least they're enthusiastic and they have some basic fundamental skills. And I lean toward initially new people coming right out of school, generally with a master's or bachelor's degree. Because what I wanted was people who had the necessary skill levels, but did not cost as much. And I figured I was going to have to train them anyway. Fiber optic sensors was a new field, and I'd have to invest in these people in terms of training and training time to get them up to speed. And that's what we did. The day they walked in, we'd start a course on how to do fiber sensors, and then we'd have on-the-job training after that. But we basically would spend a lot of time getting people up to speed. Okay. For service functions, again, I would like accounting and legal help or whatever I needed. That would be I'd hire out. You would also need, and one of the things I was very cognizant of was I wanted to get the right mix of people. I wanted to get people that would have backgrounds that would broaden out my own. It turned out I had a math physics background, but I also wound up in engineering, surprisingly enough, when I got hired into this electro-optics applied physics group. So I got broadened while I was in grad school into aerospace and mechanical engineering a little bit, but I needed to hire a mechanical engineer. I wanted to hire people who had a broad background in electrical, physical, chemical, whatever, computer science and software programming that was broader than my own. So the idea is to have a mix of people to try and have a broad experience, because with a project, you're going to need all these different types of backgrounds to handle it. The other thing I wanted to do was I wanted to have a flat organization. I wanted to have one where we all were working together on projects. And so to avoid having jealousy or other things come about with the second in command, I basically avoided that as long as possible, but we'd have group leaders or multiple people, and I'd kind of, for a while, I was rotating, well, who's in charge if I had to be on travel or whatever. Eventually, I did get somebody to be my second, if you like, but not until we had about 15 people. The other thing is most small high-tech businesses are highly matrix, which means you have projects and you have skill sets. And you have people moving between projects, and you have teams that move between projects with this different mixture of skill sets, and you do that projects. And that's really the way to, I think, set up a small business. This hierarchy stuff of having a bunch of managers or whatever, or somebody that only does one thing, is not really the way to go. Ideally, you have people cross-trained, they can do a bunch of different things, and that's the way to handle a bunch of small projects. Another thing to recognize is that you need to bring in new business, and a lot of time will be consumed by this, and you want to have everybody in the organization trained to handle marketing. So when you interact with customers, it's with the idea of doing the best job you can and helping your customers so they'll come back to you another time. You want to have them exposed to as much as you possibly can. So one of the things that we did courses. We did courses for our customers, and we charged them a fee for taking the course. And I'd have as many people engaged working for me in these courses, so they get to meet the customers. The customers would get to know them. And ideally, they take the course, and some of them would come back and be long-term customers. And that happened repeatedly. For networking, I try to get people to conferences and workshops if I possibly could. If the fees were too high, we would just rotate badges. Maybe we'd have an exhibit booth and we'd have one badge for the technical side, and we could have people in the exhibit area as many as we'd want. We'd just rotate throughout the conference and do the best we could with what we had. And we'd have people try and be personal with emails and write the customers as we went along. Call people, low-cost website. And the point here is we develop a customer base, and we keep track of the customer base. We keep track of the most important ones. We try and make sure we got to the customer site. We stayed in contact with the customer. We stayed visible. We'd write proposals sometimes to new organizations. We'd hope for getting, even if we lost, some feedback, and maybe we'd go see them to see whether or not we could generate them into a customer. The important thing to keep in mind here is that once you have a customer, you want to do everything you possibly can to keep that customer over time. I've had some customers for decades, 20, 30 years or more. So basically, once you get a customer, try really, really hard to make sure that customer is getting what they need and want. There's issues associated with who owns what, with patents and joint developments and so on and so forth. So if you have a partner or you're doing something with another company, make sure that's carefully defined. If you have somebody come along with an offer downstream, this is really important. If you're selling your company or merging into another company, try to do it very, very carefully Cash works a whole lot better than stock. I did a stock swap, and the company eventually went bankrupt with Blue Road Research a few years later, and it was really bad. So get everything in writing. Try and be really careful about what happens if a company you merge into goes bankrupt, if you do a stock swap. And if you get cash, that can work out really well too. So that's, looking back, that's what I should have done. For other exit strategies, you can hand things off to family, employees. You can have employees back, essentially buy the company back. If things go really bad, you can just dissolve the company. You could market to large and small companies if you want to do some sort of merger or acquisition, or in my case, they came to me. Okay, so I've summarized pretty quickly aspects of starting a high-tech business, even in Troutdale, Oregon, or anywhere in probably any place. You know, some of the aspects are very, very similar anywhere on the planet. It isn't easy, and success depends upon you having adequate resources, perseverance and effort, and expecting this. Well, most of the time it takes around 5 years. Of the 3 to 5 years, 5 years is more probable if things go well. And you just have to keep at it, or don't even start. So I'll try and take any questions you have and stop there.
Awesome. Thank you, Eric. That was wonderful. We have quite a few questions in the chat. I think maybe I can just read them out, and maybe you
Okay.
can let me know what you think. The first question is, starting an R&D organization can be challenging, provided that any country or local government would want to give all their resources to their state-owned R&D companies. How did you mitigate the challenges of receiving funding or working with government organizations?
Well, the nice thing in the US is that there is a mandate for the funding, 2% of the funding. So if you have a DoD budget, and it's a large budget for R&D, so the defense budget could include funding to the Army, Navy, Air Force, all have their budgets. And then you have places like DARPA, they have a mandate to set aside 2% for new business. And so you can access that pool in competition with other small businesses. And when I got started with my first company, they were just starting the program, and it had been in existence for a couple of years. The problem and the reason that they started that program was because otherwise the government would fund their own organizations. Like the Navy would fund the Naval Research Lab, or the Naval Undersea Center, or NAVAIR, or all these Navy organizations would get almost all the funds. Same with the Air Force, same with the Army. But by having that set aside, these organizations would have to think about, well, what do we really want a small business to do for us? And what happened was they started allocating these solicitations out to the public. Anybody could bid on them, and you were in competition with everybody else. And the problem in my case was, well, some of these other little businesses had been in business for a while. They were bigger, they had a bigger track record. And for me to compete as an individual, I had to team. So I wound up teaming with Sandia Lab, a big DoD Sandia Livermore lab, and Stanford on my first SBIR win. So, and I had done stuff prior to submitting that proposal, and I had a new winning idea. And I had also seen the people, I knew the people at NASA Langley who had put out the solicitation from my years at McDonnell Douglas. I had visited them a number of times, and they were aware of what I had done at McDonnell Douglas. So I was not an unknown quantity. I was familiar with the customer. I had teammates with Sandia National Labs and Stanford who were pretty well known and regarded, and they took a chance on me for a 6-month SBIR contract and worked like crazy on that 6 months because it's kind of like a paid proposal. And the chance, it was like, I think $60,000. And I wound up, and it's cost, essentially not cost plus fixed fee, it was just a fixed price contract, so I could spend as much as I wanted on it. So I spent a lot of time, a lot of effort. Everything worked out. I demonstrated that a multi-axis strain sensor, which did not exist, that could be used for composite monitoring, could be done, and submitted a phase 2 proposal, and I had $600,000 for 2 years, or maybe it was 500 or 600. For me, that enabled me to hire people and get started. And so now I had a baseline technology. I had, instead of one person, I had 3. And what I started to do was come up with other inventions, other things came out. I had these partnerships. I started to partner with Boeing for aircraft. And eventually I started partnering with Thiokol, which became ATK, Orbital Thiokol. It's now part of Northrop Grumman, on rockets. So those were the 2 primary partners that I had for aerospace, Boeing and Northrop. And I'd go around with the people at Boeing who I met. Actually, both of those companies, the personnel I needed to know, came to my courses. And when they came to the courses, they were up to speed on what I was doing. They saw the facilities. They knew what I'd done and planned. And so they were more than happy to tootle around with me. And if I won a contract, I'd give them a significant part of the contract. So they would essentially be paid to help me. I had access to first-class facilities, initially at Sandia National Labs and to a lesser extent at Stanford, but mainly Sandia National Labs in Livermore, at Boeing, at Northrop Grumman. And so that was the model that I was using, was to team with an organization that had the facilities I needed, people I needed that were beyond the capabilities of the company I had. And that enabled me to compete with anybody, basically. I think we won about, well, maybe for every phase 1 we won, well, at 2 to 1. We'd won 1/2 of the phase 2s from every phase 1 we won, but we won about 25 or 30 of those contracts, with phase 1 and phase 2 being separate contracts. And on the commercial side, people would have something they wanted to do, maybe bridge monitoring and what have you, and off they go. For civil structures, the efforts with the Oregon DOT enabled us to do some initial work on bridge monitoring. We did some of the first, well, probably one of the first bridges ever used fiber gratings to do health monitoring on a bridge in the gorge about 25 miles down the road from us. And that enabled us eventually to win a contract from NSF of phase 1 and phase 2 with the University of California in San Diego, and we got involved with the University of Delaware on composite materials. And so our network built as we got into more and more different areas, and teaming
Yeah.
is the key.
Oh, that's amazing. I'm just going to go through some more of these questions for you. One is, what are the challenges of switching from sole proprietorship to LLC to S Corp as the organization grows over the year? Is it recommended to start small with an LLC, then switch to an S Corp?
If you're starting by yourself, I'd recommend starting with an LLC. It's really easy to do. It gives you some liability protection. So that's where I would start. If you're working full time and starting something, I'd start with an LLC.
Okay.
There are some rules on debt and, like carrying back wages and stuff if you switch. If you know that you're going to have a bunch of people involved and you want to grow, I think and are willing to reinvest the money that the company makes, starting with a C corporation is not a bad idea. So the people I've known that have gone directly to a C corporation were selling stuff, like remarketing hardware, and they were actually making some money, and they'd start with a C corp and then grow it from there. But I think starting as an LLC is the way to start. I would, an S corporation, I don't know if I'd recommend an S corporation, but you can do that if you have a partner and you talk it through, and who's investing and who's working and who owns what and how you're going to handle the tax situation with an S corporation is you really need to be careful with that and avoid misunderstandings, unless you're absolutely sure the person you're working with is not going to take advantage of you.
Gotcha.
Mhm.
So one more question. Given your long and successful track record for establishing a small business, what would you have done differently, either from a technical or market or business sales perspective?
Well, I probably would have tried to do exactly what I did in the initial stages, but going along, especially for selling the business or accepting the merger, I would have cashed out for sure. I would not have, I would just basically said, forget it. I don't know what you guys are really offering. And I would have insisted that, okay, it would be a strictly cash business. And for stock, if you want to give me stock options to stick around, that's great. But I would keep the stock options, because if you're one of the key employees of a company that you merge into, and they need you to basically have the company have a really good chance of success, they're going to give you stock options. So you don't need stock. So I would basically recommend, if you get to the point where some company comes along and wonders, well, what would you do? What do we need to do to make you actually accept our offer? Make sure it's a cash offer. Make sure you're happy with the cash offer. And, tell them, well, if you want me to stick around, you need to provide me with stock options. and if they succeed, great. You'll do wonderfully with the stock options. Well, and if they don't succeed, yeah, well, you haven't lost anything. So that was
Yep.
probably my major mistake with the transition between Blue Road Research and things getting out of control.
I see.
Yeah.
Okay. Well, yeah, we have a few. We just have like maybe 2 or 3 more minutes. It was just
Okay.
there's another question, which is, have you considered venture capital when starting a business?
Yes, the venture capital. When I was at McDonnell Douglas, I had an oil and gas company that wanted me to do work that we had been doing. And at this point, I was more deeply, well, I was doing a whole bunch of things. I had lots of different projects. And a guy came in who I talked to outside of actually McDonnell Douglas in the sort of the lobby outside. And he offered me a $2 million check to get started on the stuff that we had more or less put aside. And like that day, he is willing to write a check to McDonnell Douglas that day for $2 million. And I went into the my management and said, hey, this guy's out there with, he said to write a check today for $2 million to start a project, to start it. And this was when oil and gas was, really thriving at the moment. And my manager went, nope, don't do it. You're doing too much good stuff. We're interested in billion-dollar companies. We don't want to mess around with a $2 million sideshow. Similar thing kind of happened with Sandia Livermore. But anyway, I don't know if it was related or not, but maybe about 6 months later, a couple of venture capitalists who I didn't ask me if I would meet with them in the evening. And they wanted me to start a company. But I was quite happy with what I was doing with McDonnell Douglas. I liked the people and the situation. I was very happy with it. And I told them no. The people who were running the company in the end, the management shifted in the company we merged into with the stock swap. They were venture capitalists and they basically are, they wanted to get a big return on their investment. And they made a stupid decision. Well, stupid. I mean, they made a decision to expand the company too rapidly, buying a big MEMS manufacturing facility in the Bay Area. It was too much. The company collapsed, went bankrupt, and the same people that caused problems with, during that cycle outbid me for trying to get thorough research back. And they pulled money out of the company rather than, sink money into it to try and get it back out of its feet. Anyway, I've got a really bad taste in my mouth, or if you like, experience with venture capitalists. And I kind of would be really, really careful if you have a venture capitalist come along. You'd have to make sure if you have any investor that they're doing you some good, they can add value to what you're doing, and they're not just going to take you for a financial ride down the hole. Otherwise, if you get into a situation where you're burning cash to try and get to where you need to be for a stable situation, they may encourage you to burn cash faster than you need to. You may or may not have the time to achieve a stable condition. And I would say if you take it on, you have a great idea, if you have a great idea and financial backing, and maybe in that case, maybe we could have got a couple $1 million from somebody to start things up, and maybe it would have been okay. But anyway, I'm dubious. I mean, you have to be, it's riskier, but you might succeed. If it's somebody else's money, maybe you'd be willing to take a flyer.
Hi, Brandon. This is Lauren. So we are past the time allotment. However, we still have a really strong attendance. So if we wanted to just continue on for another 5 minutes, we can. If there's any pressing questions in the chat window.
Yeah. Okay. But would you be open to taking another question or two?
Sure.
Yeah. Okay. So let's see. Another question that we had was, if an industry is capital heavy, like semiconductor manufacturing rather than IC design, is it not an appropriate startup target, or is there a strategy to achieve that? So I guess the question is, if something is capital heavy, requires a lot of costs, how would you do a startup, or if it's possible?
What I did was I did not look to compete directly with any technology that existed. When you get back to the chart, if I kind of backtrack here, maybe I can find it. Maybe I'll just talk to it, but I might be able to find it. But the key thing is you need a technology that is both technically and economically compelling. So this last line here is really important. And generally, if you have a new technology, it won't be capital heavy because nobody else is out there to compete with you. So like for fiber optics and fiber optic sensors in general, when I got started in 77, there were no communication lines. Actually, the first really demonstrations of fiber optic systems were fiber gyros and undersea acoustic sensing were the things that really were going. And it took MCI, or what became Sprint, some years before they're using multi-mode fiber. So if you're in a technology that's in the early stage, or nothing else exists out there, and you have, a technically compelling argument, like for Blue Road Research, I knew that there were problems. I knew from a customer point of view that they wanted to measure three-dimensional strain internal to composite materials, and there was not a good solution. So technically, that was compelling. And I didn't have to worry too much about economic costs because nobody else could do it at the time. But if I went out and I said, well, I want to compete with a conventional strain gauge, which costs $5, $10, anybody can put it onto the outside of a structural part, that would make no sense whatsoever, because I could not buy a greeting for less than a couple $100 at the time. So if you have to pay $200 for the basic component, you're competing with an industry that has strain gauges for maybe $5 or $10 or even less. And they've got already the readout systems and everything else, and your readout system might cost $5,000 or $10,000. There's no way you can compete. So there was no way I could compete with an entrenched technology unless I had a completely compelling technical solution that they couldn't do. There's no way an electrical strain gauge can handle multidimensional strain still today, whereas a fiber optic grading strain sensor written to PM fiber can do that. And I came up with that idea a couple of years into Blue Road Research. But I knew the problem existed at McDonnell Douglas because we had like an $18 million contract that included, among other things, how the heck do you do that? And I tried all sorts of things and none of them really worked very well. So I was still thinking about that problem years later. And that turned out to be the right thing to pick. And the same thing with the pressure temperature sensor, which was a derivative of the multi-axis thing, turned out to be really important. It had both of those conditions. But if you start out and you're competing with an entrenched company that already has a base in terms of manufacturing, in terms of customers, and you do something that's equivalent, even if you get it down to the same price, which is doubtful, you're probably going to have problems because the customers are used to these other people's products and they're not going to buy yours. So you need to find something unique and compelling. And that's what I did, both for Blue Road Research, and later when I left Blue Road Research, I didn't want to do anything that I had done in Blue Road Research. And I went looking around for a while before I found another niche that was really high-speed systems to measure velocity and position in energetic material. That was a requirement that came out of Lawrence Livermore, which happened to be right across the street from Sandia Livermore, but I'd never really been in there talking to them, and they gave me some problems that they needed to solve, and I solved it, and that led to other SBIR wins from Edwards Air Force Base and Army Missile Command. And I had a product line, and that product line enabled me to have internal products and internal government contracts. But because I had this network out there with experience in small businesses, I had people coming to me. I had a medical company come to me asking for help in robotic surgery. And I helped them come up with a solution to how to do robotic surgery or with essentially a new technique to help essentially do spatial orientation. So you have one end of a fiber and the other end of the fiber, and you're moving it through veins and through the heart, and you want to get to a specific area of the heart without doing any imaging, any radiation. Essentially, what they were doing was robotic surgery to repair a short circuit in the heart. They would stick in a probe with an RF cutter into the blood vessel, run it through a membrane in the middle of the heart, and you get to the region that you need to cut because the heart is short-circuiting. And originally they did this with X-ray fluorescence. So you're reading the patient continually with X-rays. And that's bad for the patient, turned out to be bad for the doctor. So they developed these robotic systems that could do this function remotely. That's good for the doctor, but it's still not great for the patient. So what you wanted to do was have a way of having an initial starting point and actually have a bunch of strain sensors in a single fiber head, really small to get through these arteries that might be blocked, and give you three-dimensional navigation all the way to the point you need it to be so you can minimize the X-ray exposure. Anyway, I got deeply involved in that. But customers were coming to me with their problems. I would work on trying to help them address the problems, and they owned all the technology and patents and stuff that came out of that. So I was doing R&D for them. So that was the combination of Columbia Gorge Research. Yeah.
And I think we've now come to our time allotment. There are still a few more questions, and I've talked amongst staff that we might do a Q&A within our newsroom. And I just wanted to remind everyone that we will be sharing the recording as well as the presentation with all that have registered. We also, within the next few days, will have the webinar up on our website, as well as